Hello and welcome again. Here's some advice on the CANSAT competition because there's some stuff that we really would have loved to have had in a nice presentation, which I hope we can provide for you. So, to start, plan ahead. I mean, it's quite obvious. CANSAT can be very, very difficult to get started with, so our first piece of advice is to not be intimidated and leave it to the last minute, because if you leave it to the last minute, you will suffer. It will be painful. Programming components and building circuits is important, but having a full diagram of what you want to do first makes it so much easier. Another thing with buying components and making stuff, using the Adafruit website and using their Adafruit components is usually the best course of action, alongside looking at what previous teams have done, because quite a lot of previous teams have put up their um PDRs and CDRs that detail what they did use. And this is really useful because you can learn from both other people's mistakes, and you can also have the official Adafruit guide on how to put everything together, and they also provide you with code, which saves a lot of time and makes it much easier to have a good, solid starting base. This is a very annoying diagram, but it's pretty basic actually. It's just showing each component connecting, and it has all the connections that you want to plug into the Arduino Nano. That's just something that's quite useful, but yeah. It doesn't have to be coloured, doesn't have to be labelled. You don't even have to know what the connections are initially. You just have to make sure you know that everything connects correctly to your microcontroller, because if it doesn't, you're going to have to buy extra components. And yeah, it's the gist of what you want to do. Budget, yeah, budget's important. If you can get your school or whatever organisation you're doing it with to cover as much of the CANSAT budget as possible, it is very nice. And of course, having a budget for that allows you to just go, I don't know, to your teacher if you're doing it for school and go, well, hello, this is what we've spent. How much can you pay us for this? So we haven't had to cover everything out of our own money. It's important to consider all components, not just electrical components, especially when building the CANSAT. If you're not 3D printing it and you don't have like a quote from someone, if you're making it out of, I don't know, like a can, or if you're buying like, I don't know, carbon fiber or something, or steel or aluminum to make it out of, you've got to consider that material. Things like nylon as well for the parachute is important to consider. Cost shouldn't be too much of an issue. It's not very easy to go too much over the budget, but to know where your budget is and how much you can push it is rather useful. Mechanical design is a pain, because you just have to review this, and quite a lot of the time you won't know what's wrong just from making the CAD model. You need to make a CAD model, if you can, get someone to 3D print it. If you have a 3D printer available somewhere where you can just make prototypes, it's very useful. Of course you can do it with, I don't know, cardboard or something, but it's much more helpful with the 3D printer, which we did have. So just remaking it again and again, and then every time it comes, looking at it and going, what's wrong? What might we need to improve? What could be a problem? And then just going again. So for example, this initial design that we have here, not so much, well, we had a large problem that we encountered once we printed it, which is that this component that I'm circling, we had no way to actually get the motor into there, which meant that we couldn't really use it. And then this design in general, it's theoretically a good design if we didn't have such a small size limitation, but because there are fins on the edge, there's like this area all the way around that's cut off, and so we lose a lot of space, which is quite a bit of a problem. And so you don't want issues like this when you're just putting everything together last minute, or if you're, you know, like, oh, this is the first time we're actually using it properly. You just got to make sure everything's correct first, otherwise you might run into quite a few problems. And yeah, that's basically it. I mean, comment if you have any questions, but those were the main things. The other main thing, I guess, just as a side note, is what microcontroller you're using. This is part of planning ahead. If you want to use the Arduino Nano, which is quite useful because Adafruit do just give you code for it and, well, starting code on how each component works at least. And there are quite a lot of guides and they have forums. It seems slightly harder to do it with Raspberry Pi, and if you use an unknown microcontroller, good luck on connecting stuff to that, because, well, I'm sure it is possible, it's not entirely plausible that things will be compatible with it. And yeah, that's it. Thank you for watching, and yeah.